Hello guys, so in this video we are going to take an example of take an equation and solve it using Chinese remainder theorem. So the equation here is x is congruent to 2 mod 5 and x is congruent to 3 mod 7. Okay, so first we want to find the value of x. So the first thing we are going to check is basically the modulus are relatively prime or not. So what do I mean is that we will check what is the GCD of 5 and 7, and the GCD of 5 and 7 is 1, and since it is relatively prime, this can be solved using Chinese remainder theorem. So this 5 and 7 are basically these two values, this and this, 5 and 7. Okay, so since it is the GCD is 1, we know that as per Chinese remainder theorem, the value of x will be I equals to 1 to 2, since there are just two equations here, m upon mi, ai and bi. Okay, now m is what? M equals to m1 into m2 in this case, since there are just two equations, and m1 equals to 5 and m2 equals to 7. Right, similarly here a1 equals to 2 and a2 equals to 3. Right, so this a1 and a2 are these, right? This is a1 and this is a2. Okay, so now the missing term is bi. So let us look at what is the value of bi. Well, bi is the multiplicative inverse of m by mi. Okay, so bi is the multiplicative inverse of m over mi. And how do we find multiplicative inverse? Well, the multiplicative inverse is something which can be found out using extended Euclidean algorithm. So let us apply extended Euclidean algorithm to find the values of b1 and b2. So let us work on b1 first. b1. So in order to find b1, we know that GCD of m upon m1 comma m1 is 1. Okay, so I have done a video wherein I have talked in detail about the proof of Chinese remainder theorem. If you are confused why the GCD is 1, please refer to that video in order to get to know why the GCD of m upon m1 comma m1 is 1. All right, so now for now we will just assume that we know that this is 1, so let us rewrite it now. So this is GCD of what is the value of m. M is basically 5 into 7 divided by 5, okay, comma 5 equals to 1. So let us look at it. So this is basically GCD of 7 comma 5, right, equals to 1. So let us compute the value of GCD 7 comma 5. Okay, so this we know that 2 times, and then we have 5 over here, 4 and 1. So this is basically 7 is equals to 5 into 1 plus 2, and similarly 5 equals to 2 into 2 plus 1, right? So I'm writing it down from here. 7 equals to 5 into 1 plus 2, and similarly 5 equals to 2 into 2 plus 1. Okay, by the way, again, I have done an exhaustive video on extended Euclidean algorithm too. If you are interested, please feel free to look into it. Okay, fine. Coming back to this, so here 2 is equals to, we can rewrite it as 2 equals to 7 minus 5, and this 1 can be rewritten as 5 minus 2 into 2. Okay, so now expanding on it further, equals to 5. And what is the value of 2? Well, the value of 2 we can plug it from here. So 2 equals to 7 minus 5. So now let us write it down. So 1 equals to basically 3 times 5 minus 2 times 7, right? And here we wanted to find out the multiplicative inverse of m upon mi. All right, so the multiplicative inverse of m upon mi is this. M upon mi is this, right? So m upon mi is 7, and we want to find out the multiplicative inverse of this 7. So the multiplicative inverse of 7 is basically our b1, and that is equals to minus 2. Okay, so this is the multiplicative inverse. Okay, now let us look at b2. So for b2 we know that GCD of m upon m2 comma m2 equals to 1. So this is basically saying that GCD of 5 into 7, and this time what is the value of m2? Well, m2 is what? M2 is 7. So let us plug it. 7 comma 7 equals to 1. So this is essentially saying that GCD of 5 comma 7 equals to 1, and we have already used extended Euclidean algorithm to find the value of GCD of 7 comma 5. So GCD of 7 comma 5 is GCD of 5 comma 7. So we can use the same equation, which is this, in order to find the multiplicative inverse. So remember, in this particular case we want to find the multiplicative inverse of what? M upon m2, right? M upon m2. M upon m2 is what? This, and m upon m2, if we translate it, this is 5. So m upon m2 is 5. The multiplicative inverse is what? The multiplicative inverse of 5 is what? 3. So b2 equals to 3. Okay, now let us plug these values and get the value. Let us get our value of x. So we know that x equals to I equals to 1 to 2 ai bi m upon mi. Okay, so let's expand it. A1 b1 m upon m1, a2 b2 m upon m2. Okay, and let us write down the values of b1 and b2. So we know that b1 equals to, what was the value of b1? b1 equals to minus 2. Okay, let me just write it down here. b2 equals to 3, and a1 is what? a1 is 2, a2 is 3, and m1 is 5, and m2 is 7. Okay, so let's plug all these values here, and yeah, let's plug all these values here. So what we will get is basically a1 is 2, b1 is minus 2. Okay, and this is what? 5 into 7 divided by 5 plus 3 into 3, since a1 and a2 and b2 are 3, and this is what? 5 into 7 divided by 7. So if we solve this, you will get x equals to 17. Okay, so this is the value of x. So x equals to 17 is something which is going to satisfy the equation, this equation. Okay, so and if you want to check it out, well, x equals to 17. So if you divide 17 by 5, the remainder is 2, and if you divide 17 by 7, then the remainder is 3, right? 7 times 2 is 14, and the remainder is 3. 5 times 3 is 15, and the remainder is 2. Okay, so that's how you use CRT theorem to find the values of x. That's about this video, folks. If you have any questions or confusion regarding this video, please feel free to use comment section and I'll try to address them. Thank you.